Okay, hello folks. This little video is for the phone home system that we're developing in R&D at e-NABLE. We'll start off with our hardware, which is this Huzzah ESP8266 breakout board from Adafruit. It's only $9 and it's frequently out of stock, so put in your notification and get them when you can. Actually, we're going to be moving to the Feather platform next thing, but I want you to be able to duplicate my results precisely. So you got this board. There's two of them in the mail to Charles, and I have four more. I can spare two. I want to keep two of them just for experimenting. And also, I want to point out two things. Here is the link to the tutorial at the very bottom over here, and in the bold text. Our essential tutorial has wiring, pinouts, assembly, downloads, and more. That's really good. And then way at the bottom of the page, we have this thing. This is an FTDI friend. So we're going to plug this end, the mini B end, into a mini B connector, plug this end into the ESP8266 board, and then finally plug the USB into the computer. I find that's the best order for doing it. Then, once you have that connected, there's a little button sequence that you go through. See, I'll show you the buttons. Here is the board. This little thing is a single pole, single throw switch. GPIO0 it's connected to. And this is another identical little switch. It says reset. What we're going to do is we're going to press and hold the GPIO0 button and squeeze another finger on this teeny little board and push the reset, release the reset, and then finally release the GPIO0 pin. When we do that, the LED, which is in here somewhere, I haven't identified, there it is, that's got to be the LED right there. It will change from bright red to dim red. And the dim color, the dim brightness, indicates that it's ready for programming. So we will call up our Arduino software. To the right is the software, and to the left we have the wonderful serial monitor. Now let us upload. We got to compile it. It'll compile it automatically, but anyway, it compiles clean. And let us press the upload button. So it's showing us a progress bar, and it's programming with a blinking display of lights that you can't see because they're on the boards, and they are going, and they go for a while. Once they're done, the ESP8266 chip will wake up as an access point. And that means that it shows up in the list of Wi-Fi access points. Here in the serial monitor, it tells us the IP address 192.168.4.1. If we didn't use the serial monitor, we can go to our network preferences where we have previously selected e-NABLE, and you will have to select it from this list. And there in your network preferences, it'll show you the local IP address of the computer, which is 192.168.4.2. Well, if you see this, you got to realize that the last digit we want to change to a 1 because it's the access point and apparently it's got to be a 1. I don't know, I'm just winging it. You may know better as to why. So anyway, with that number in mind, we open up our web browser, we type 1, and we previously had this, so let's hit enter, and hopefully this time, there we go. We get a web page. This web page here is now the front end for the chip. It could be your phone, it could be your tablet, it could be your Mac PC or Linux, any device that has a network and a web browser can be the front end for this chip, and the chip is going on the prosthetic, so the prosthetic can host, can have this a front end. So anything you want to do that you can do with a web page, you can do that in the chip's code, and it can display that. You know, play games, do diagnostics, remind people of stuff. That can all be done through the phone. Okay, now we're showing guests. When it does a network scan, it lists all the devices and all of the access points, and the SSID for the devices is the same as the access point. Kind of weird. But anyway, you pick one. I've got to add code to make this just be one. That shows up one time, but anyway. Alright, click. Now it will serve us up another web page. Here, please enter your local network password, and I will do that now. Okay, hit enter. And, well, you can see what it was right up there. Thank you for entering your network information, phoning home now. We gotta make this hidden. This is a no-no. Okay. And the ESP8266 is blinking. If we go back to the Arduino software, Arduino IDE, we can see that a lot of stuff has happened here. I don't know exactly what, but here, bad request, what? Can you guess? Wi-Fi connected to the guest. I don't know. Let's find out what actually happened by going to, alright, we need to go to our guest account. Well, let me do that here. Pardon my delay here. The guest account will connect me back to the internet. We're off the device, and the device is now sending messages. To where? To this log entry, where I'm going to reload it. Okay. It reloaded. Scrolling down to the bottom, we see some kind of network delay. Let's stop it and start it again. Go to the bottom. Here we are today, 5/06/2016 at 11:44 here, or 10:44. No, that says 11:44 because that's where the server is. But we are here in Central Time, and it says 10:45 for us. So this device, I think I have it going. Let's check the Arduino code. I have the timing. The timing interval is 60 seconds, yeah. So every 60 seconds, that this guy here going to reload him, reload it, is going to have another entry, 4453, 460, there's the 4342. Okay, this is our device number, which is built into the chip. Each chip has a unique device number, or supposedly does. And this is the battery voltage. Actually, I don't have the resistive divider or anything hooked up to the analog I/O pin, so this is kind of a random number. It's not that random. It's due to the electronics on the thing with the protection diodes and the diode, whatever it is, the diode O-ring. So anyway, long story short, we are sending data to webapp.enable.me, which is our cloud at e-NABLE, and it's appearing in the list here. Ta-da! That's about it. So, yeah, things that we need to do is, like, this software, it kind of crashes if you enter the wrong password. It runs off, it goes nowhere. So we want it, if the password is wrong, we want it to come back and ask again. Then we want it to remember multiple sites so that if the child is at home, it has the web, the home network, and if the child is at school, it has the web of the school network, and it can remember them all and try one in a certain order until they work. And there's just a host of other features and stuff. You know, we want to maybe use that scan as a feature. Of course, we want to add all kind of sensors possibly, but I'm rambling. Let's put an end to the video because you can gather all that kind of stuff through other means. So you're gonna hit that button. There it is. Okay. Let's make it happen. See y'all later. Bye-bye.